I'm Terence Law, and I'm a PhD student at Georgia Tech. For this talk, I'll be presenting some of our exciting findings from a review of systems that automatically communicate data insights to users. I want to start my talk with this mind-blowing quote. The purpose of visualization is insight, not pictures. Because providing insight is such an important goal of visual data analysis, visualization researchers have developed systems that automatically extract and communicate data insights to blow users' mind. So this is quick insights in Power BI. When you load your data into the tool, it automatically generates a page of statistical facts about your data set. And there are many systems that have a very similar nature. All these systems aim to automatically communicate data insights by recommending potentially interesting visualizations or by generating textual descriptions of statistical facts in a data set. This fascinating space of tools raises many interesting questions. For example, quite a number of them use the term insights to describe what they do. But we all know that insight is an overloaded term, and so it is not clear what they mean by insight. We also observed that these tools are designed for many different purposes. Many of them are designed for data exploration, but more recent tools aim to facilitate communication and some other purposes. So we were interested in learning more about the types of insights these tools provide and the purposes of providing these insights. And so we've conducted a systematic literature review to create a framework of types and purposes. So here's some nomenclature before I dive into the paper collection process and our findings. In our paper, we define automatically generated insights or auto-insights as data observations created by automation that are presented as charts or textual descriptions. It is a reasonable definition because this definition captures what the developers of these systems mean when they use the term insight. And we call these systems that automatically extract and communicate auto-insights as auto-insight tools. With these definitions in mind, we collected 12 papers as the seed papers. 10 seed papers come from a recent blog post about visualization recommendation systems written by Lee. The other 2 seed papers are 2 recent publications at VIS about systems that automatically generate textual descriptions of statistical facts. With the 12 seed papers, we iteratively collected papers cited by the seed papers and the papers citing the seed papers. In the end, we collected 20 papers that describe some auto-insight tools. And with these 20 auto-insight tools, we coded the types of auto-insights they provide and the purposes of providing auto-insights. And so here are our findings. From the set of papers we reviewed, we identified 12 types of auto-insights and 4 purposes of providing these insights. So this bar chart shows the frequency of occurrence for each type of auto-insights. The most common type of auto-insights is outliers. It can be outliers in a numerical variable, in 2 numerical variables, or in a time series. The view-based Explorer is an example. It recommends outliers in 2 numerical variables. And what it does is it enables users to rank the scatter plots based on whether there are some outlying points in the scatter plots. For the sake of time, I wouldn't go over the other types, and I encourage you to read the paper for the details. And so here is another bar chart for the purposes of providing auto insights. We can see that the most commonly cited purpose is exploratory analysis. The developers of many of these auto insight tools claim that during data exploration, there are many charts users need to explore, and by enumerating the charts, assigning a score to the charts and ranking them, users can review fewer charts. The view-space explorer is again a good example. If you have n attributes, there are n times n minus 1 divided by 2 scatter plots you can explore during exploratory analysis. But if I rank the scatter plots based on a metric like correlation, you can immediately see the ones that are highly correlated. And this reduces the number of scatter plots you need to look at to find the highly correlated ones. Besides data exploration, some of the goals have emerged more recently, like supporting communication. So users may not know how to interpret a visualization. Some of these tools provide textual descriptions to facilitate visualization interpretation. And another purpose is focused analysis. These tools allow users to specify a high-level question like, what is the difference between US and European cities, and get suggestions. And the final purpose is to support data wrangling, which appears in only one tool. The Profiler tool automatically mines data quality issues and recommends charts to visualize the issues. So, what are the design opportunities? If we look at these types of auto insights again, we can see that not many tools support compound facts, or in other words, facts that contain multiple facts. So future auto insight tools could provide more nuanced auto insights by merging different pieces of information and using more sophisticated generation logics. Another observation is the emerging use of these systems beyond exploratory analysis. There are tools that are used in communication and focused analysis, and it would be interesting to know how these auto insight tools can be applied for other use cases. In the paper, we have a more in-depth discussion of the design opportunities emerged from our literature review, so take a look at the paper. So we feel that automated insights are an exciting and growing research area. It would be really, really awesome to see more novel techniques to generate data insights and studies of these techniques. With that, thank you for watching this talk.